Hey guys, this is Vanessa. I just wanted to talk about this slide here that you're looking at in the slideshow about energy and matter. So, first, a couple of things I want to review. Obviously, we know that all living things need energy. It's how we do stuff, it's how we breathe, it's how we eat, it's how we procreate, it's how we move. It's how our bodies function. And so every living thing needs energy to function. If it doesn't have energy, then it dies, which is basically why if you don't eat food, you die. Your body needs calories, energy to run. Another thing is remember now that uh, our energy in an ecosystem comes from outside the ecosystem. It either comes from light energy, like you can see here, from the sun, or it comes from chemical energy from a place like a thermal vent deep in an ocean trench. And lastly, we have to remember always that energy cannot ever just disappear. It has to go somewhere. All right. So what we're going to look at in this slide is uh, how does the energy transform in an ecosystem, and where does it go eventually? All right. So we're going to start here. Let's start with the light energy at the bottom. So this is our outside source of energy, right? And it goes to our primary producers. These are our autotrophs. Auto means you can do something yourself, and the thing that producers can do by themselves is use light energy or chemical energy to make sugars. So autotrophs and primary producers like trees and plants and algae and some bacteria, a few other things, use sunlight energy to create sugars. All right. They also provide oxygen at the same time, but oxygen for plants is actually just a waste product that they're trying to get rid of. What they're after is the sugars, the glucose with the calories that they need to do stuff. It's their food. Um, all right, so these are eaten by primary producers, like all these little guys, like insects, birds, could be something like a deer. I'm a primary consumer. Sorry, primary consumer. I'm a vegetarian, so I'm a primary consumer right here. Um, the thing is, when this energy goes from the producer to the consumers, there's this law of thermodynamics that tells us that it's not an efficient process, okay? Some of the energy is always lost as heat, and in fact, it's quite a bit of the energy. So you can see if I start out with 20,000 kilocalories, which is quite a bit of energy in these plants, right? And then let's say it's an apple tree, and let's say I'm a primary consumer and I eat that apple. I'm going to use 10% of the calories or the energy in that apple to help me do stuff, to help me live. But 90% of that energy is going to be lost as heat. And that happens every time you hop up another trophic level. Each of these is called a trophic level in a food pyramid or a food chain, until you get to the point where you may have started out with 20,000 kilocalories worth of energy, but by the time it gets to a quaternary consumer, like a hawk or a lion or something like that, all but 2 kilocalories of that have been lost as heat. Okay, um, so that's a pretty big deal. So, for an example, let's say I take 1,000 calorie apple, which is outrageous. There is no such thing, but I take 1,000 calorie apple from a tree and I eat it. I'm going to use 100 of those calories, burn it doing regular day to day stuff. Most of that, in fact, 900 of those calories are going to be lost to heat. Okay, which we know, like if you work out, you sweat. That's heat. But then if I take a walk in the woods and get eaten by a bear, um, the bear is only going to get 10% of my 10% of the apple's calories. So the apple initially was 1,000 calories. I only got 100 of that. Okay. And then by the time the bear absorbs that calories by eating me, uh, you'll have lost 90% more. So he'll only get 10 calories of that. And then if something were to eat the bear, I can't think of what, but I don't know, a pack of wolves, right? They'd only get one of the calories that was originally in the apple. Everything else just leaves our bodies, and oftentimes the ecosystem is heat. Okay, so energy leaves. It doesn't disappear. It's never destroyed. It just travels somewhere else. All right. So that's the deal with this loss of energy in the form of calories as we go up the chain of consumers. You can see eventually, if nothing eats this quaternary or tertiary consumer and eventually it just dies, it's going to be broken down by decomposers. But you can see here, even the decomposers are losing a bunch of that energy as heat because it takes worms and bacteria and fungi energy to do what they do too. So, big takeaways. Energy is cycled through a system in a really inefficient way. It comes in as light energy. These primary producers are awesome. They make a lot out of that sunlight energy, but then every time it travels up the food chain, we lose a lot of it. Okay, and there's no way to get it back unless some of it gets recycled and as decomposers break it down. But most of it just has to come back to us again through more light energy. Okay, so if you have any questions about that, let me know. But this is a really important slide. Pay attention to it because we'll have some problems on our first quiz where you're working out the math about how much energy we lose at each stage. Yeah, that's it for now. Thank you guys.